Hello and welcome to Beginners Python and Machine Learning. My name's Tim Cummings. Tonight we're doing an absolute beginners session. So this is for people who've never seen Python before. It's cool. We're doing absolute beginners number 2, getting started number 2. So it does follow on from a previous one, but if you didn't see the previous one, that's okay. We'll go over that stuff. Now, we're going to run through some Python. It's an interactive session, so feel free to talk to me on the YouTube chat, or even better on the Slack chat. So we'll be listening on this channel here, Learning to Code, and there's instructions below the YouTube video in the comments said how to get an account so you can join up. But if you haven't got an account, then try using the YouTube chat, and hopefully I'll see that and be able to respond. In the YouTube comments and also in the Meetup comments, you'll see a link here to Google Colab. So we're going to use Google Colab tonight, and that means that we don't need to have Python installed on our computer. Colab gives us an interactive Python that we can run. It runs on a server in the cloud, and it gives us our results immediately, so we can, as we type in our Python commands, we can get the results straight away. And so it's a really good way of learning, because you can see exactly what each command is doing. So the best thing to do, you'll need a Google account, but just click on the link either below the YouTube video or in the Meetup. I'll click on this one now, and that will go to Google Colab. You can go there just directly, but you won't have this pre-filled file then. And you'll be able to view it in like a read-only mode. The first thing I'd recommend doing is clicking on this button here, which says Copy to Drive, and then you'll be able to save all the changes that you make into your Google account. So that's opened up a new tab here, and it's given it a new name, which is Copy of Meetup 118. And here is our notebook. So Google Colab uses Jupyter Notebooks, and so all the stuff that if you know Jupyter Notebooks, then you'll be able to use them here in Google Colab. If not, we're going to show you how to use it. So for recap, Jupyter Notebooks, you'll notice Jupyter Notebooks is a bunch of cells. So you can see here, this is a cell, it's got this rectangle around it. Here's another one, here's another one. And these cells can be either text or code, and you can see you can put new cells in. You can put in a new code cell or put in a new text cell, and that'll insert it in between these existing cells. So with the code cells, you can actually run them, and to run them you can have your cursor in the cell and type Shift-Enter, or you can click on the play button. You see there's a little play button there, and that'll run the cell, or and Control-Enter also works. If you look in Tools, Keyboard Shortcuts up here, you'll be able to see all the keyboard shortcuts for moving around in Google Colab. So you can see here, Shift-Enter is run cell and select the next cell, and Control-Enter is just run the focused cell. So they do pretty much the same thing. Now I'm going to just go along. If I don't get any questions, I'll assume that everyone's keeping up. So, but it is an absolute beginner session, so feel free to ask any question, and I'm happy to go over anything again. It doesn't matter if we don't get through the whole notebook tonight. The important thing is that we answer your questions. If I don't answer the question, someone else who's watching may also answer the question. Okay, so let's go to the first cell, and we've got a little couple of lines of Python here. We've got import sys and print sys.version, and you can see all this green text that all starts with this hash sign, and the hash sign says that's just all comments. So Python's just going to ignore all the green because it's all after these hash signs. So it's just going to run these two lines, imports this and prints this.version, and that will tell us what version of Python we're running. So if I do Shift Enter, you can see it's selected the next cell, and it's running this one. Now the very first one you run is going to take a bit of time, because you can see up here that it's now connecting, it's now initializing a new area on a server for you to run your Python commands. And there we go, it's running Python version 3.7.12. So on my computer I've got version 3.9.5 installed, so it's a couple of versions old, but it'll do for what we're doing tonight. So if you remember from the first Getting Started Absolute Beginners session, we looked at a few ways of storing data in variables. So variables are just memory locations that we give them a name, and we can change what data is stored in them. That's why they're called variables, and they can store different types. So I've given a few names here. I've just called all of them with the word my and the data type I want to use. So my int, my float, my bool. You can call them pretty much anything you want, except for Python keywords, and try not to call them something of an existing Python function, because you will then stop that existing Python function from working. The convention in Python is to, for a variable name that's multiple words, to separate the words with an underscore, and to do the whole variable name in lowercase. So if I put these commands here and then run it, there's no output. It just does nothing. It just stores those values in the variables so they can be used later, but there's no output that comes back to us. So let's look at how Python knows the different data types that we've typed in. So my int, we've typed the number 5, so it knows that's an integer because that's just a number by itself. My float is a floating point number, and the reason it knows that that's not an integer is because we've put a decimal point after the number 5. So we could have said 5.123, and that would also be in a float. So if you want to make sure Python knows you're putting in a float, then put the decimal point in, otherwise it'll just assume it's an integer. A bool is a boolean, and that can be either true or false. So those are two keywords, true and false, and they have a capital letter. So true has a capital T and false has a capital F. Now here's a string. A string is text, and what we learned last time is we can tell Python we're putting in a string by putting quotation marks around it. So those quotation marks can be either double quotes like we've got here, or it could be single quotes. In our case, we've got an apostrophe in the middle of our string, so it's better for us to use double quotes on the outside, and then we can use single quotes without any trouble on the inside of the string. This next variable is a list, which is a collection of different values, and you can see we've got inside the list we've put an integer, a floating point number, a boolean, and a string. And we've told Python it's a list by enclosing it in square brackets. Now if we'd used parentheses, then it would have been a tuple, not a list. And here's my tuple, which we've converted the list to a tuple by calling the tuple function. And a tuple is an immutable form of a list. A lot of people call it tuple as well. Either way is fine. Alright, so we've run this cell. We've run this cell, and see that's where number 2 on it. And now we want to see what's in some of these variables. So we've put out the variable name. We say my string and my tuple, and have a look at what's inside of them. Now we're not seeing my string, because Jupyter Notebooks only display the output from what's on the last line here, and so my tuple. So we're seeing what's in my tuple, so it's our integer, our floating point, our boolean, and our string. And you can see it's got parentheses around it so that we know that it's a tuple. Now, some people won't be using interactive Python, which is what Jupyter Notebooks is. They'll be using straight Python. So in straight Python, just putting a variable name on a line doesn't do anything. If you want to see the value of a variable, you have to put it in a print, use the print function. And so here's an example of using print functions to see the values of the variables. And this first one is a simple form of the print function. It's just a string inside the parentheses, and that's what it'll print. But these other ones, I'm using format strings, and I thought we'd just jump right into the deep end here and use these format strings, and you can see that they're a really useful way of displaying values of expressions. So to make it a format string, we've put an F outside of the double quotes, and that's everything that's inside the quotes, double quotes. That could be single quotes. It could be any sort of quoted string, but you have to have the F out the front. And then anything that's just in there will be displayed literally, but anything that's in curly braces will be evaluated. So our variable name myInt will be evaluated, and it'll give us the number 5. So let's have a look at that. And here's the output of that cell in our Jupyter Notebook, printing using format strings. And so you can see the first one, myInt, a colon, and then the value. myInt, a colon, and then the value. My float, my bool, my string. So you can get some really nice output using those formatted strings. Now what I'm going to do, I'm going to share this notebook just in case. I haven't typed in anything yet, but sometimes I'm going to type in extra things into this notebook, and so you can follow along this one as well. Anyone with the link can view it. Copy the link. So I'll post this into the YouTube chat and into Slack. And that link will work throughout the session tonight, and so refreshing it, you'll be able to see anything that I've typed into here. I'm not saving outputs, so I've got emit code cell output when saving the notebook, so you're not going to see any output, but you can generate the output yourself because none of these things take long. Okay, so still recapping, here's a tuple that we've defined with these parentheses, and it's a collection of all these strings that are names of the first 21 numbers starting from 0. So we've written a little loop here. This is called a while loop, and when we have a loop, we have to be able to show which of the text, which of the lines of code are going to be looped. And Python does it a bit differently to other programming languages. It does it by looking at indentation. So all of these lines have been indented by 4 spaces. And that's a setting I've set for Google Colab. Google Colab by default I think is 2 spaces, but either will work, 2 or 4. And the code block starts with a colon here, so everything after that is indented. And so it'll run these lines. We'll start off this first line and say I equals 0. Is I less than the length of numbers, which is 21, so it is true. So it'll start running all the lines in the code block. When it gets to the end of the code block, after it increases I plus by 1, it'll go back to the while statement, and repeat checking this conditional to see if I is still less than the length of the numbers. And so as I keeps increasing, eventually I will be equal to the length of numbers, and this loop won't run anymore. So just these few lines of code, I've managed to show a way of converting every integer as digits into a name of the number as a string. And you can see I've done a little bit of stuff here in the formatting of it. I've right aligned these numbers so that the 9 lines up with the 0 in 10 and the 1 in 11. And the way I've done that is in these format strings, it has an expression before the colon that's going to get displayed, and then after the colon is a format of how you want it displayed. And I want it to be 4 characters wide, and the greater than sign, I want it to be right aligned. So here we've got 4 characters, and the numbers are hard pushed up to the right hand side. Okay, so we want to write our Python program to convert these numbers to text, which is a good little program that we've got here. We want to use a bigger range than 0 to 20. So we could try just increasing the numbers in the tuple. So I could add this tuple to our existing numbers, and then I'll have 3 more names in there, and then I'll be able to so yeah, if I look at numbers now, you can see it goes all the way up to 23. But this doesn't scale very well. Like, it'll scale up to 23, that's okay, but if I wanted to go to 1 million, that's a very big tuple that I'd have to write, and it's a lot of work for someone to type in all those names. So the idea is to try to get the computer to do all the work. Alright, so you can see it works. We've got I equals 22, and we look, numbers of I gives us the name 20-2. Alright, so I can delete the last 3 numbers from the tuple to create a new tuple by using this slicing notation. This is, I'm assuming you've seen this. If you haven't seen it from our last session, then let me know. I'm very happy to go over that again, but that's just saying start from the beginning and go all the way up to 3 before the end, and create a new tuple from that, and that'll take us back to our original tuple of numbers, which goes up to 20 and stops there. Alright, I might make this a bit bigger so you can see it more easily. Okay, so one thing we could do for our program that we're trying to write that will calculate the text name of a number is calculate the name by joining the name for the tens with the name for the units. We've already got the names for the units, so we just need to know what the names of the tens are. So we could add 20 and 3 and create 23. 30 and 5 will give us 35. And then we just use a formula to work out how to combine those. So if I put all the tens in a tuple like this and print them out, see what I get. Tens equals that. There's our tuple. And you see how there it's just using single quoted strings in the display, even though we had double quoted strings. It really doesn't matter which way they go, they're both equivalent. Alright, so if I want to convert, say, 27, I'd get the rightmost number, the 7, and I do that using modulo arithmetic. So that's I modulo 10 is I, what's the remainder when I divide I by 10? So 27 divided by 10 is 2 remainder 7. So the remainder is 7, so that goes into the variable right. And left is equal to 27, which is I, minus the modulo, which is 7, and that will give us 20. So we'll get left should be 20 and right will be 7. Let's have a look at that. and you're alright, we get 20 and 7. So you see the print statement here is just put a comma there, and it just prints all the values. You can have as many commas as you like, and it's just put a space in between them. So how would we do that as words? Well, we could look at the tens tuple here, and we want to get 20. So that's left floor division 10 minus 2. So that's 27 divided by 10. Integer division is 2. Minus 2 is 0, so we get the 0th index in this tuple, which is 20. And the right number is 7, so we could look at our numbers tuple and index 7, and that will give us the word 7. So that's correct. We're getting 20 from using our tens tuple and our left variable, and 7 from our numbers tuple and our right variable. So let's try that for a whole bunch of numbers. So we'll try it for this group of numbers here. We've got 27, 52, 5, 12, 30. We'll calculate right, because we've got a formula for that. We'll calculate left, because we've got a formula for that. And then we'll display it, the left number, then a dash, and then the right number, and get the text name of those numbers. So can anyone predict what how this is going to work? Do you think it's going to work correctly? Can you see any problems with what we're about to do here? Well, let's run it and see. So 27 is 20 plus 7, and we get 20-7. So that worked great, just like we wanted. 52 is 50 plus 2, and that translates into 50-2. Once again, looking good. 5 translates into 0 plus 5. Our little formula is showing us 85. 12 is coming up as 92, and 30 is coming up as 30-0. So you can see a couple of problems in there when we use these index. This index here, when it goes negative, it starts counting from the back end of the list, and so that's why it's starting to use 80 and 90. And when the right number is a 0, it's still printing a 0 there, 30-0, and that's not how we do numbers. We just do 30. So we've got to think how we're going to change this little program here so that it handles every case. All right, in fact, that's our first task. So the task 1, fix the above code so that all the names of numbers display correctly. You need to check for numbers less than 20 and numbers evenly divisible by 10. All right, so let's write this code. We've got some pseudocode here. Oh, this actually, no, it's not pseudocode. This is how we can use an if statement in Python. So we say if, and then we put a conditional, and a conditional is something checking for true or false. And then anything we type in here in this code block will be what happens if the conditional is true. Then we use else if, condition 2, and we do everything in here if condition 1 is false, but condition 2 is true. And then we've got a final else, and we do that if the condition 1 is false and the condition 2 is false. So what are the things we've got to check for? Check for numbers less than 20. All right, so let's do that. If I is less than 20, what do we do? Well, this is like 5 and 12. We're catching this case here. All we need to do is just use the numbers tuple straight away. So we can print I, and we can print numbers with index I. That's good. And then I go back to the beginning because I've finished that code block. So I remove the indentation, and that's when I put in my else if. So now I need to check if a number is evenly divisible by 10. So I could say if I modulo 10 equals 0, then I know it's evenly divisible by 10. And in that case, I just want to print the So what are we doing? We're going to calculate, fix the above code. Yeah, we're going to use this code up here. So we've got left and right calculated. So because left is calculated, I can just print this part. So I'm not using format strings here, so this is an easy way of using print statements. It doesn't give us much detail, but it might be easier for you to understand. So, and certainly if you're doing the challenge, you don't need to go into format strings at this stage, just try to get the answers right. Okay, and else, so that's if both of those are false, then we can print, and we'll print all of this. And we'll do it without format strings, so I'll show you how we do that. So we're going to concatenate these strings. So numbers right is a string, the dash is a string, and tens left is a string. And so by putting pluses between these strings, it'll concatenate them all together, which means just join them up into one long string. Alright, now we want to use that with this code that we've already got. So I'll copy that code again because we want to run through that loop. So we're in the loop, and we need to, because we're already in an indented code block, we have to further indent. So I'll just indent all of this code. We don't need this print statement here. And so if we run that, we get 27, 20-7, that looks good, 52, 50-2, 5, so 5's coming into this part of the if statement, and so it just takes it straight from numbers. 12, once again, takes it straight from numbers and it displays correctly, and 30 is this part. This is where the modulo 10 equals 0, so it's displaying correctly as well. So we've answered the task. So these tasks are a great idea for you to have a go at yourself. So if you're doing this live, then pause the video, have a go at it, and then run it again. And maybe even if you're doing it live, you can run it at double speed just to catch up to me, or 1.5 times speed, so that you can catch up to where we're up to. If you're doing it in retrospectively, then you don't even need to. Sorry, if you're doing it in the future, then it's all re-recorded, so it's not live anyway, so you don't have to run it at fast speed to catch up. Alright, let's look at the solution. So it's very similar that was provided. Rather than typing in 20 here, we've gone for length of numbers, and that means it's just going to calculate that each time. We've used formatted strings throughout. Oh, here's another way of checking if it's divisible by 10, is just check if right equals 0. So it does the same thing as what I've done if I modulo 10 equals 0. And that's right, because I modulo 10 is right. So we have already calculated I modulo 10. So yeah, that's all the trick we need to do. Let's run it just to make sure. And that all comes out in nicely printed format with format strings. Okay, so this expression here that we use to calculate the index that we need for the tens tuple, it's a little bit complicated. It would be good if we could just say tens 20 and it would give us 20, and tens 30 and it would give us 30. So we could do that with a sparse tuple, where just lots of empty fields in it, and then just a value at every 10 numbers. but that's inefficient from a memory perspective, and could also be quite hard to type in as you're getting big ones. So Python has a dictionary data type where you can set the keys and the values, and it knows it's a dictionary because it's got these curly braces surrounding it. So there's inside the curly braces you put these key value pairs. So there's a key is the number 20, and then a colon, and then what the value is, which is a string with TWE and TY. And so now we can just look at what, say, for example, 10's 40 is, and that will just give us 40. So now that's a lot easier to pull the 10's out. So we should be able to use that in our code. These keys don't have to be numeric even. You can have strings for keys. So here's an example using A, B, and C. And if you print it out, it shows those key value pairs. And then you can use those strings in the index rather than a number in the index. You can even use tuples in the index. So, for example, this number pair here, 1, 4, will be the index for this string here, bottom left. And the reason you can do that is because tuples are a read-only data type. They're immutable. It basically has to be hashable, but immutable means you need to be immutable to be hashable, which means it can't be changed once it's been created. And so tuples are like that. So you can't use lists, for example. Okay, and here's an example of using as a list. Now I've commented it out because it's going to throw an error, but I'll uncomment it so we can run it and see the error. And there's the error, type error, unhashable type list. And that's what we've got there. So I'm going to comment that out again. And the reason I've done that is because if someone's trying to run all the cells in this Jupyter Notebook at once, if it comes to an error, it'll stop there and won't get to the end. Right, with our dictionary we can add new keys and values. So remember we set the initial keys and values just by using these curly braces and key value pairs. But we can set new values by using this index notation. So D in square brackets, the string D we want to be delta, and the string E we want to be epsilon. So let's have a look at what D is after we've run these two lines. And you can see there's your A, B, and C, and now it's added D and E onto the end. Now say we want to update this dictionary, or another way of adding data is using the update function. And what that does is it will apply all the key value pairs out of this dictionary to the existing dictionary. So it basically merges that dictionary here to this one. And you can see that in the merge our E epsilon got replaced with E echo, and we also got the new one F foxtrot added on. Now we can call some methods. I mean, update was a method that we called on that dictionary. We can also find out all the keys in the dictionary. We can find out all the values in the dictionary, or we can find out all the key value pairs in the dictionary, and they're called items. So it can be useful to have all them. So here's d.keys is equal to this data type dict keys, and it just gives you the keys without the values. Dict values gives you all the values without the keys, and dict items gives you both. And it's just showing that these are the data types of those responses, but really you can treat them as though that was a list, and that's also a list of tuples. Now when you're looping through a dictionary, you would say you wanted to find every key in the dictionary, you could say for k in d.keys, but there's a shorthand for that. You don't even have to put the d.keys, you can just put d, and that'll assume that you're looping through the keys. So in that case, we've k goes for every value in there, which is a, b, c, d, e, f. We then work out the value of each key value pair by putting k into the index of d, and then we get both the key and the value from that dictionary. And here it is: A alpha, B bravo, C Charlie, etc. It's pretty common that you would want to get both the key and the value. So in that case, you would use d.items as your range of values that you're looping through, and you can have two variables here as the loop variables, and the first value in each pair will go into variable k, and the second value in each pair will go into v. So let's have a look at what that produces. It should be the same. So it's just made it a little bit easier to get the key and the value and reduce the amount of code. Alright, task 2. Redo task 1 using a dictionary for tens. Okay, so I'm just going to copy our solution I'll copy this solution here for task 1, and we're going to use our new dictionary of tens and see how we go. So our left and right calculations can still be the same. We've got numbers, tens here, and now we've got our left number, which is for example, in 27 it'll be 20, and then we were dividing by 10 and subtracting 2. We don't need to do that anymore, because tens is a dictionary. I think that's all the change we need to make. It is. There we go. So that makes it a bit easier to read the code because we're using a dictionary. Let's have a look at the answer. Yep, that's all they did too. Okay, task 3. So there's another task for you. You see, I've left an empty cell here for you to do it, and you can create new cells if you want as well, just by adding code cells, and you can create a few cells in there and have a go at it. And at any point, if you want to have a look at a value of something, you just throw an extra code cell in there and have a look at the value. And the values are calculated on the order that you run the cells, not the order that they are in the notebook, which you would normally run from top to bottom. But you can see that's why they show the number there. There's like number 25 for that cell, and this one hasn't been run yet, because each time you run a cell, it affects values of variables that you're storing. We should run this solution just to make sure they get the right answer. They do. So I could see that they hadn't run that because it was at a blank there. Alright, so expand solution to task 2 to handle numbers up to 999. Test on these values, 100. Okay, so let's go with our simple solution not using format strings. And we'll put a few extra numbers in there that we're going to test. Alright, and let's just run it and see what we're going to get. Right, so when we get to 100, we get a problem with this line here, because it's our tens only goes up to 90, and we don't have anything after that. Alright, but really we want it to show the number 100. So let's calculate here. So first of all, right, we're calculating the number of tens. Let's calculate the number of hundreds. we'll call it h equals the number of hundreds, and that's just going to be I percent so this is one way we're going to do it. We'll work out the number of hundreds. If h is greater than 0, then we want to print how many hundreds it's going to be. So it can be 100, 300, 900. And we can get that from numbers h. Because we don't want 0, 100, which would be these ones. Let's just put this into a string. S equals numbers 100 plus and okay. And then we can say I, and we'll just subtract the number of hundreds that we've got. All right, and then when we print any of these numbers, we can put, we'll just put an S in there. Okay, so I don't need that last space. S is not defined, that's right, so we have to put an else in here. S equals nothing. There we go. So we've got 27, 52, 5, 12, 30. They all still work properly. 1, and I should put in 100, and 12, 100 and 0, 112, 300 and 0, 999. Okay, so that's looking pretty good. The only one that's wrong there is 100 and 0. So in that case, we can just print if I equals 0, then we'll just print straight away. And we don't want the and. Yeah, so that was not a great way of doing it. If I does not equal 0, S plus and how are we going to get rid of that 0, 1 there? If I is less than 20, if I equals 0, I comma S. And then that becomes an else if. 100, I just like S plus equals 112, 300, 999. Oh, look, I'm not even getting these. So I need to think a little bit about what I'm doing here. But that's really plus I plus h times 100. So it's a bit of a mess, but it's good to just write down what you're thinking and get some code working, and then you can clean it up afterwards. 999, 300, 112, 100. Yep, so they're all working. So there's some messy code that will give you the answer. And once you write down that, you can look at some other code and go, oh yeah, that was probably a better way of doing it. So let's look at this solution. So the hundreds number is equal to I divided by 100, so that's right. If it's greater than 0, then we want to have the hundreds name. Well, that's pretty similar to what I've done. And we've got the conjunction. And right, so we've just changed when we use the conjunction. We don't use it on the if the remainder equals 0, but we've used it here in all the other cases. So how do we get around the 0 case? If remainder equals 0 and hundreds name does not equal, oh, okay, so if it's 0, it comes in at this point. If it's not 0, but it's a round number of hundreds, it comes in at this point. And that's what we get. And this code's doing a little bit more because it's actually doing this breakdown for us as well. Okay, well, it's not a lot different to what we had. Any questions so far? I hope you're following, and I hope you're having a go at these exercises, because they are fun to see what you can come up with. Some cleaner code. You might be able to come up with something a bit cleaner than that. Fewer lines maybe. Alright, so let's look at functions now. We have some code which works for numbers from 0 to 999, but we don't have to copy those 18 lines of code every time we want to use them. We can put the code into a function and then call the function when needed. So let's talk a bit about functions. There's a few functions here: help, print, license, copyright. They're all built-in functions that come with Python, and they just run the same time every time you run them. So for example, help's quite a good one. So I'll uncomment that and run that, and you can see it brings in Python's help utility, and you can type in things here and it will search on that. So let's try help on print, and so that's given us some help on the built-in function print, and it will give us some more help there. So how do we get out of this? I'm going to press the pause button there, and we'll get rid of that. Now in interactive Python, you can also use the question mark, and that brings up help over here. It tells you all about interactive Python, and you can also do the question mark on a particular function, so help on print, and you see it's brought up the doc string here for print and tells you how you can use print. So that's pretty useful, and you can just close these when you want to. Now here's another built-in function. It's just the print function that just prints a blank line. Here's the copyright function, and that just prints a bit of the copyright information about Python. And you can see the functions can return a value, and you can store that return value into variables. So I've called that value here return value. But if we look at what the value is of copyright, and it's just none. So it's not actually it's returning the none value rather than a particular value. So functions can return the none value, or they can return an actual value. Here's an example of functions can take arguments, and so you put the arguments between the parentheses, and you're used to that because we've been doing the print statements for a while now, and we've been just putting in what we want printed as arguments to that print function. So here's an example of print with 3 arguments, and you can see it's got 3 arguments because the arguments are separated by commas. And in this case, prints that each argument and puts a space in between them. So you can see there's a space there between arguments and 2, and there's another space there between 2 and 3. This is the way to do a print statement with 1 argument. So when you use format strings, you're generally using 1 argument in the print statement. This is the other way of doing print statements, which is using several arguments. But the format string, you can then evaluate expressions in, as you've seen. So we can put example into where S1 is, and 3 minus 2 is 1 argument. So let's run that. An example of print with 1 argument. This argument is a string, which is the result of the format string being evaluated. Functions can also have named arguments. Named arguments must be used after positional arguments and can be in any order. So here's an example of no named arguments, as you've seen, and then these are named arguments, and you see you've got the name of the argument followed by an equal sign and then what you want the argument to be. So let's run it and see what we're going to get. That's what you'd expect for the first one. Example of print with no named arguments, with no named arguments. Now here we've said the separator is going to be a dash instead of a space, and the end character is going to be a space rather than a new line. So here we go, example dash of dash print space. So there's our 3 arguments, example of and print, and we've put a dash in between each one. And then we've got with named arguments, and so between each one of those we want underscores. So yep, now we've got underscores, and at the end we want to have less than new line, less than new line. So this is useful if you want to print something and but don't want to drop a new line, because later on you want to print some other stuff that's going to be on the same line. That's where you'd use end equals space, for example. These are some built-in functions: minimum, sum, max. They're all just using examples with positional arguments. So the minimum of 487.2.5 is 2.5. The sum of all of those is 83.4. The max of those is C, and the max can take like a bunch of positioned arguments, or it can take a list of those arguments. But sum, for example, can only take 1 argument, but it has to be something iterable. So if you wanted to find out about sum, we can use that help sum just to see more about it. And you can see here we've put SUM, but we haven't put the parentheses. So even though sum is a function, if you do it without the parentheses, then it treats it as an object, and then we can find help on it, and it tells us about it. So sum requires an iterable. An iterable is something like a list or a tuple, and that's what we've used there as a tuple. Okay, now I've got a question here from Leo, and he said, in solution 1, why did you use if I is less than length of numbers rather than just a number? So that was the reason I do that is because it future-proofs my code. If, for example, some reason I want to put the first 30 numbers in numbers rather than just the first 20, then all I have to do is add those extra ones into numbers, and then my code will automatically use the extra ones that are there rather than calculating it every time. And the reason I would do that is that's effectively caching those values so it could increase performance. So if I was doing a lot of numbers between 20 and 30, then rather than calculate each time, I'd store the answers in that tuple or list and just display them straight without having to calculate them each time. So it's just if you think there's any place that you're likely to make a change to your code, you try to write your code in a way that your other code in a way that is not going to be affected by that change. All right, methods are functions attached to classes. Now, I'm just showing you a lot of this stuff. You don't really have to remember that this is called a method or this is called a function, but I'm just making you aware of them at this stage because you are just beginners in this thing. So just this stuff is really just background knowledge at the moment. But here we go. Here's some examples. We're calling functions on objects, and so that we're using methods. So we've got a string, and we're calling the upper method on that. So remember, string was beginners Python and machine learning, and there it is, all in uppercase. So that returns a new string. It doesn't convert the existing string. It just returns a new string that is all in uppercase, and this returns a new string that's all in lowercase. But if I look at what's in string, so I'll just add what's in my string, you can still see it's just the original string there with in title case. All right, there's the string object has a title method, and what that does is it looks for all the words and then puts a capital letter on each new word, which in the case of Bob's Diner looks pretty silly, so I don't really think it's a very useful function, but it's there. Split will split on a particular character. By default it's white space, so it'll split on that white space and produce a list of all those strings that have been split by where the white space has been. But you can put a different character in there if you want to split on a different character, like you could split on B's and you'd get OS Diner, something like that. Now the important thing is defining our own functions. So we've shown you what the sort of functions we can. Any of those we could have defined ourselves. So let's try defining some of our own functions. And we use def to define a function, and then our function name, and then parentheses to say this is how many arguments this function is going to have, and in this case we're having no arguments, so it's just empty parentheses. Then a colon to say start the code block, and then all our lines of code for our function that are indented. And Python knows when it's got to the end of the function definition because it's the code is no longer indented, or in the case of interactive Python we've got to the end of this cell. So if I define that function, it doesn't actually run it, it just defines it. This function here is using a third-party library datetime. It's not third-party, it's a standard library datetime, and it's using that to calculate what the current time is. So that's why we've imported that. Alright, so now every time we run show now, it'll say the time is now, and it gives you what the time and date is. And I can run that again, and it gives us a few seconds later. Alright, so that's the example of writing a function that doesn't return anything and has no arguments, but it does something for us, which is display to the screen what the current time is. Now here's a function that returns a value, and it's going to return a Fahrenheit value based on an argument that we provide to it, which is what the current temperature is in Celsius. So we've just put in a formula here to convert from Celsius to Fahrenheit, and we define the function. Now that that function is defined, we can call it as many times as we like without having to put that formula in every time. So let's try running it on these 3 Celsius values, and I'll put a line for each one, and I'll say 0 degrees Celsius is 32 degrees Fahrenheit. 100 degrees Celsius is 212 degrees Fahrenheit, and minus 40 degrees Celsius is minus 40 degrees Fahrenheit. So that function seems to be working. Alright, now in recent versions of Python you can start putting typing information into your function. Now this is advanced information, so for beginners you can really ignore this. For the beginners, just assume that Python will work out the type that you send it, but by giving it type hints, that can be useful when you're using an IDE such as PyCharm or Visual Studio Code, and it can find errors in your code, things that you're not expecting when you're going to send out the wrong sort of data to a function. Like if you tried to send a string to this function, but you put in this type hint saying that it's expecting a float, then your IDE would give you a warning and say, you know, what are you doing sending a string here? It would still let you send the string. The code would still work. It would give you a silly answer, but or it might throw some sort of exception if it's trying to do something with that string, but the function itself will still accept it even if it's the wrong data type. The other thing that we've got here in the function, the first line we've put in what's called a doc string. So it's a string because it's enclosed in quotes, and this is the triple double quotes way of defining a string, and that lets you put in carriage returns inside the string as well. So we've got a multi-line string here. If we now find help on our function that we've just defined, it says it takes one argument called degrees Celsius. The type of that argument is a floating point number. It's going to return a floating point number, and then the text describes what it's going to do. It returns the temperature in degrees Fahrenheit given the temperature in degrees Celsius, and then lots of paragraphs here of extra description if you want to. Alright, you can also get to that using this special variable here, underscore underscore doc underscore underscore, and you might hear Pythonistas calling that dunder doc because it's double dunder for double underscore. So if I look at what's in there, once again that's that string as a string. Oh yes, so here's an example of sending the wrong data type. So we know it's expecting a floating point number, but let's send it a complex number. So complex numbers, for those who like maths, that's j is the square root of -1. So you can actually use complex numbers in Python. 24 plus 5j is 24 plus 5 times the square root of -1. So let's see what the temperature is then. So that in Celsius will give you this in Fahrenheit, which doesn't mean anything, but it still worked even though we defined that the type. We can put in a type hint. Okay, convert the code from task 3 into a function and return a string. Okay, code from task 3. So let's find the code from task 3, solution 3. I'll just use mine. So to define a function, we'll call it, I can see what they've called it, so we'll call it the same thing, number name. We'll just call it I is our value that we're sending to it. And I'll paste in what we had. Now we had a bunch of I's, so we'll just use that. And now we need to return a string. So we'll just put a different return on each one of these lines. And we want a space between those two. Yep. Space, 10's left, dash, that looks all good. Get rid of those parentheses. Alright, and let's test that it works. So we have to call it, and we'll just give it a number. We'll give it 134. 134. So we've defined the function here. We've then run the function, passing it in a value 134. The return value has come back here, and then it's, because it's the last line in an interactive Python cell, Jupyter Notebook cell, it's displayed that result here for us, 134. So let's have a look at the solution. That's all looking similar. In fact, they've done pretty much the same way we did before. We've just converted those print statements to returning strings. So that's all looking good. And then they've run the test over all the values before, so that was a good idea. So let's have a look. And that worked. That worked as well. So we've done pretty similar. I can't see much different in that. We've put up here the doc string. We've put in here some type hinting for the argument value. We've put in some type hinting for the return value. All good. All right, expand solution 4 to handle thousands up to 20,999. All right, let's have a go at that. We'll use that solution this time, which is actually a solution I wrote but a while ago. And we want to test it for up to 20,999. Right, so what are we going to do here? Well, we can do thousands equals the number divided by 1,000. So if it was thousands, we're just going to say 3,000, 4,000, 19,000, but we're not going to say 0,000. Okay. So if similar to the hundreds, if thousands is greater than 0, then we want to do something. Thousands name equals numbers of how many thousands there are plus a space and then the word thousand. We don't have a conjunction between thousands and hundreds. 3,432, 3,032. We will need a conjunction if there's no hundreds, but there is another number after it. Okay, well, think about that when time comes. So thousands name and that has to be on a new line and indented. That is the name equals that, so that's good. Number equals 0 and hundreds name does not equal 0, does not equal empty string. Okay, I guess we've got to do so we're going to do this again. Number minus equals hundreds times 100. So let's do something like that. number minus equals. So number minus equals means subtract it from the existing number and store the result in the original variable. Alright. And then it calculates the hundreds. That's good. And hundreds name does not equal that. Or thousands name. Why don't we just do that? So we have to think of all the different situations, and this is why this is such a good problem, because we already know what all the different ways of doing these numbers are in our head, but there's a fair amount of logic required in doing that. Can we convert that logic that we know in our head into Python code? Plus hundreds name. Okay. Let's see how close we got. 20,900. We want and 99. Hmm. 999. Let's put in. We'll see if we'll get 1,000. See if that worked. 1,001. 1,030. 1,100 and 24. 33. So 1,000 worked, 1,001 didn't work, 1,100. Okay, so we've got some problem in that when we're subtracting the thousands, we're losing the rest of it, but we are getting the hundreds, but we're not getting these ones. So number minus equals thousands times 1,000. So we can put some debugging into here. So that'll be after the 1,000. So we'll just say print 1,000, and then we'll put some in after the 100. And see what number is then. So we get a lot more output. So after 100, number is 112. After 100, it's 12. 112. So that's come good. 1,000. After 1,001, we get 1,000. Then after 1,000, we get 30. Oh, sorry, 1,001. We get 1,000. We get 1. 100. We get 1. 1,000 and 1. 1,000. So it must be our code here. Let's just get rid of these ones. So we're only looking at the problem ones. One thousand number. So number is not equal to 0, so it's not doing that. Number is less than it is, so it should be 1,000, correct, plus number's number. So I'm not seeing why it's not running this bit of code here. So I'll just put in some logging here to say number is less than 20. And it's not triggering that bit of code. So number minus right, number equals 0. So let's have a look at this one. $1,001.21, so that's 21. If number equals 0, return thousand's name. Oh, I know what the problem is. I want to make that or happen. We always want that, but that's we've got to can have either of those ones. There we go. 1001, 1030, 1123. So everything's working well, except if we've got no hundreds, we're missing the and sign. So let's save time. We'll go and have a look at the answer and see how we've done it here. So thousands. So we've started with a string. So we're constructing a string for the solution, and we're just adding to the string as we go through. And the advantage that has is that after we've done the thousands and the hundreds, then we can just work out whether to put a conjunction in based on whether that s does not equal an empty string, and that's really seeing if there's thousands or hundreds. So it's a complicated piece of logic here, but when we run it, that gets all the right answers: 1,000, 1,200, 12,345. All right, so task 6 is even more advanced. Expand the solution 5 to handle numbers up to billions. Okay, now I'm just going to run straight through the provided answer here, but it's a really good exercise to work through yourself. And what the trick is to notice that there's a pattern here. So when you're programming, always look for patterns. So we've got all this code here for thousands. We've then got code here for hundreds, and then the conjunction stuff. So if we did millions, we'd have code for millions, then thousands, then hundreds. Then we'd have billions, then millions, then thousands, then hundreds. And then looking at that code, you've got a pattern there. Is it possible to write this code in a way that you can loop through it? And the solution that we've come up with here is to use a dictionary that stores all these powers that we want to check. So we check the 100, we check the 1,000, we check the million, the billion, and the trillion. And you see I've put here dictionaries retain their order since Python 3.6. So if you're using Python 3.6 or later and you create a dictionary like this, you can be confident that it will go through in that order. It'll start with trillion, it'll then go to billion, it'll then go to million, 1,000, and 100. But if you're using an earlier version than 3.6, if you create a dictionary like this, they could get randomly shuffled up. So just be aware of what Python version you're using. But because we're doing that, we can then loop through those powers one at a time and do the sum. So count equals the number divided by the power. So remember we did thousands was the number divided by 1,000. Millions will be the number divided by 1 million. Check if it's greater than 0. If it is, add it into our string using plus equals, and then subtract that value from our number and keep working down from there. Now what's even really clever here is, rather than work out how many million there were, to calculate, say for example it was 35 million, we would have to work out how to do 35. But we've already got a function that does 35, and it's the same function that we're in. So this is called a recursive call, because the function is calling itself to work out, in this case, for example, how many million there are. So that's an advanced feature. So as an absolute beginner, don't worry about it for now, but it is possible to call your own function, and you'll see that you'll get the right answers in the end. So here's our final test: 12,345,678,900,000, etc., and all from just this number of lines of code, which is not many more than we started off as, like 18 lines of code. All right, how are we going here? We've got, yep. So we've got 2 more tasks to do. Define a better function than string.title for Bob's Diner. So that's what Bob's Diner produces, which is not great, but we want it to produce Bob's Diner. So we want to split on spaces. We don't want to split on apostrophes, and then create titles from that. So let's call it better title of a string S. So we'll create a list which will be s.split based on a space, or I can leave that out, and then we just we want to join them back up with spaces, and we want to do title for each of those words. So let's create a new list of capitalized words. So we'll create new list equals that, and then we'll just go through every item in that list. So let's see, our word will be W in list, and new list, we're just going to append that word, but with a capital letter at the beginning. So the capital letter is just the first letter of the word in uppercase, and every other letter in the word in lowercase. And then we'll just join them up at the end, and we can say space dot join the list, the new list. Okay, and let's try running that on Bob's Diner. So this join function, it starts with a string. It's a method on the string, but it takes an argument of a list, and it takes every word in the list and joins them all up with whatever that string is. So if that's a space, it'll put a space between all the values in this list and create one long string, and that's a actually surprisingly useful function. And there we get Bob's Diner, and it's got a capital at the beginning of each word. So let's have a look at the solution here. It's used the join function like I did. So creating the new list, it's used this thing called list comprehension, and you'll see that a bit in Python code. It's a little bit more advanced, so maybe don't start off doing list comprehensions, but if you see it in code, you want to understand it. This is how it works. It basically takes these 2 lines of code and puts them into square brackets. So you can see there's a square bracket there and a square bracket there. There's our for loop, and there's our evaluation using that variable in the for loop for the evaluation of each value in the new list. And that's once again a common thing that people will do with lists. So that's how they've created this list comprehension, and they've so these 2 lines here can be restricted down to 1 line, which makes it easier to read and shorter code. You can even have an if statement in there, so you'll have 3 lines of code here. In fact, it's this line here as well. So we've got 3 lines of code. We've reduced down to 1 line. But if you could put an if in there as well, you could have 4 lines of code reduced down to 1 line. And we'll just check that works, and it does. You can find help on this split function if you want. And because it's a method, you'd have to say the class name before a dot and then the function name on that method, of that method. Okay, rewrite solution 7 to have a named argument set with default value none, which gets passed through to split. Okay. So default values have to be named, and you give it a so it's the argument name, and you then have to give it a default value. And once you do that, then people don't need to put in a value. If they don't put in a value, it will get it will use the default value. If you do put in a value, it'll override the default. Okay, so then we just have to pass that straight through to the split function. And if you did a help on split, you'll see that it has a default value of none already on separator, in which case it'll use any white space. So we'll just pass that straight through. We'll give it a default value here as well, and we'll be passing none through. So we'll always be passing a value through to split. So we won't be using its default value anymore, but we'll be setting what the default value is. And here is the solution. Here in the solution, they've used it as a named argument. Yes, you probably do have to name it. So let's because there's that sign there, that means oh no, that's just standard. It doesn't have to be named. So we could have just done sep, or we could do it as a named argument. And there's an example of running it with underscore as a separator. So let's see how that goes. And yep, that works. Let's put a capital letter after each time it's seen an underscore and at the beginning. Now I'm just going to quickly show you some things about packing arguments. This is really not beginner stuff, but you will see it in code. So if you've seen it once, then you've got a chance of understanding what's going on. So let's start off with these list of tab separated values. So in this string here, we've got tabs, which is this \t, and so TSV, that's what the string looks like when it gets printed out. So let's just put tabs in there. The list of arguments is \t and 4. Okay, what are we doing? Oh, okay, so we've created a list here and we've put 2 arguments into that list. Now, how can we use that list of arguments when we're running the split function? So there's one way we could do it, is we can go list arguments 0 is our first argument, list arguments 1 is our second argument. And remember, in our split function, it's looking for 2 arguments. One is the maximum split and one is the separator. So this is the first way of doing it. That's a very manual way, but that works, and you can see it works. It's split our string up by tabs, but it's only done a maximum of 4 splits, and then the last the last one it hasn't split, because that would be more than 4 splits. Alright, now here's another way of specifying the same thing, and it's a bit of a shorthand, and it's to put the asterisk there and then list arguments. And what that does, as you can see, it gives you just the same results. So typing this here, tsv.split list arg0 comma list args1 is the same as doing tsv.split asterisk list args. So that just unpacks all the values in list args, which is a list of arguments. That could be, it doesn't have to be called list args, it can be called anything you like, but it has to be a list or a tuple or some iterable sequence. And it splits them up, and we'll just apply them to those positional arguments in order. Another one that you can do, what are we doing now? We've created args, and that's a tuple rather than a list. And we're doing the same sort of thing. Yeah, so if you do a print statement and you put args in there separated by colons, it's only args is a single value, even though it's iterable, it's a single value, and there it is, it's the tuple, so it gets printed out. But if you unpack it using the asterisk, then args becomes 2 values, so rather than 1 tuple it becomes 2 strings, and then when you print it out with the separator of colon, you can see that there were 2 strings there because it's put the colon sign in between them. If you can define your own function with unnamed arguments. This is too advanced for beginners really, but that's how you would do it. So that does the opposite of, here we were unpacking, now we're packing up the arguments into one list or tuple, and you can see that it prints it out as a tuple just by calling unnamed for comma foobar, and there it comes out printed as a tuple. Keyword arguments does the same sort of thing. This was working with positional arguments, this one is now working with named arguments, same sort of thing, but we use a dictionary of name value pairs, and you can see we can put them in a different order, and it will expand out the dictionary using double asterisks. So that's for unpacking, and then when you define, and you can see it works, there it's working, and you can define your function and it will pack up lots of keyword arguments into one dictionary that you can use in your function. And so there's an example. We called this named function with these 3 arguments. They weren't defined beforehand. When we defined the function, we didn't say what the names could be anything, we said. And this is how we find out what those names are, by looking at the keys in keyword arguments. And very advanced, Python 3.8 and later, you can define position only and keyword only arguments using slash and asterisk. So if you define it that way, they can be either keyword or positional. If you define it like this, then they can only be positional because you've put this slash here. If you put an asterisk and then a comma here, then they can be only, anything after that can only be keywords. And if you want a combined example with some position only arguments, some standard only, which can be keyword or positional, and some keyword only, then you put the slash and the asterisk as arguments in your list there. And I've commented that out because it's not going to work in Google Colab because that's only running Python 3.7. But if you're running on your own computer, you might find, and you've got a later version of Python installed, you can run those definitions and it will work. Okay, so I hope you've learned something from today. I didn't get many questions, so I was just racing through it. If you next week we'll be looking at network sockets with Python. So I've it's a fun little thing. We write a server and a client just in a few lines of code and have them sending information between each other over network sockets. So it was one of the requirements we needed to know to build our virtual printer, our print to XLS printer that we wrote in Meetup 110. So I hope you'll come along next week and we'll have fun with that. After that, Arun will be doing some more machine learning stuff for a couple of weeks. So see you later.